Good morning, good afternoon, good evening, wherever you are in the world. Thanks for joining me to talk about how we built real-time full-text website search with RediSearch. My name is Andrew Brookins. I'm a developer advocate at Redis Labs. Let's get started. Okay, let's look at an agenda for the talk. So first, I'm going to start with an introduction. I'll introduce myself, and I will also introduce RediSearch, the module we used to build this project. And then I'll talk a little bit about why we wanted real-time website search. What did we hope to accomplish with this project? Then I'm going to demo what we built so that you'll pretty quickly have a visual in mind when I say, our search thing. You'll know exactly what I mean, and you'll be able to also see just how fast it is. Then I'll give a high-level overview of how it works. What are the big pieces involved? And finally, I'll show you a little bit about how we deployed it. How did we get it all over the world so that it's fast for you wherever you are? Okay, so a little bit about me. I'm Andrew Brookins. Like I said, I'm a developer advocate at Redis Labs. What that means is I make videos, I make courses, I make example projects, I make production apps, and all kinds of things to help people learn how to use Redis. So that's a bit about me, and I'm also the author of a famous computer book called The Temple of Django Database Performance. So, if that's up your alley, it's probably not at a bookstore in your area, but you can certainly find it on the internet. It has some wonderful pictures in it. Some people call me a doting father, but that remains to be seen. Let's talk about RediSearch though. RediSearch is a source available Redis module from Redis Labs. It adds querying, indexing, and full text search to Redis. You can get started because it's source available. You can get started with your own Redis instance and this module running. And then if you want to scale up, you can scale horizontally and globally with an active geo distribution from Redis Cloud. So check that out. There's a lot of amazing features in there. And we'll talk a little bit about that in the deployment section of this talk. Okay, so wanted real-time website search. What were we even doing here? Why did we build this thing? We wanted better search for our documentation. So we have a website, docs.redislabs.com, and if you go there, you can search our docs. We wanted that experience to be very fast and also just really good. So we also wanted to be able to deploy it close to most users of the site, right? So we want search to be running near you so that when you go to search for our docs, the application server is close by, but also the Redis instances is near the application server. So very low latency. Speaking to the experience of, when you actually type it in, sure, it should be fast, but also results should appear instantly. So this is not autocomplete. Autocomplete is when you're typing into a search form and the search engine returns back like terms it thinks you're looking for, words it thinks that you're searching for, and they appear as a word list. This is actually showing you the results for your query if you had made it. So we're executing your query over and over as you build up, the letters in your search terms, and they should appear instantly. We want this to be so fast it burns your hands off as you're typing, and you're just like, oh my gosh, why? It's just, did they make this so fast? Okay, let me demo what we built, and I will show you what I'm even talking about here. So let's go to a web browser. And I'm on our docs page. You can do this too from wherever you're at, docs.redislabs.com. It'll load this page, and then you can just start searching. So I like to search for Python stuff, but you can search for whatever you want. Replication, leader, follower. I guess we don't have much follower in there yet. But what you're seeing is a lot of search queries executing one after another as I build up this string, and the results appear instantly. So we did what we set out to do. We accomplished the task. Enlightenment now. So that's what we made. That's what I'm going to be talking about. That was a front-end search form, and I'm going to be talking more here about how does this work, right? How does the backend work? There's a backend search API. There's the Redis instance. How does that stuff work? So this is an overview of the indexing portion of this application. So like most search applications, there's two big pieces. There's indexing, when we actually add content into the search index, and then there's querying when somebody wants to find stuff that's in the search index. So these are the big pieces of the indexing step. This runs on a schedule, and the first step is ingestion. So we use Scrapy, which is a popular web scraping framework in the Python language. And so Scrapy is doing the initial, like, go to every website, get the content from the page, and dump it somewhere step. So we'll call that ingestion, right? We want to get the page content out. The next step is we want to transform that raw, HTML string into something packaged up for the search index. So, there's some stuff that we're just going to parse out of the HTML, like the title of the page. We'll know the URL because we get that as part of scraping. But then there's other stuff that you can't necessarily find on the page. And one of those things is the site hierarchy where that page exists. So if you think of a documentation site, there's sections in documentation, right? And sometimes it's pretty deep. So we want to be able, when we add that data into the index, we want to be able to add the entire hierarchy for the page. So we know that this thing is under this particular section. And why we want to do that is so that when we show you those search results, we want to be able to show, like, where on the site this particular page is, and group the results by where those sections that results are coming from. So anyway, we have to do some special stuff to build that site hierarchy. And then another thing we want to do is when you add items to RediSearch index, you can give documents a custom score. And so for some of these, some of the things that we add into the index, we want to give some custom scores. So you can think of this as pretty much any ad hoc logic you want to run to adjust scoring during the index time, at the time that you index something in RediSearch. That's what we're doing at this step, applying some scoring rules. Now, after we've bundled all that stuff up, so we have like a custom score if we've applied some scoring rules to something, and we also built the site hierarchy, and we've got the content that we want to index, the title, the URL, all that stuff, then we add that to Redis. So the way that RediSearch 2.0 works is it's going to index hashes in the background, right? So all we have to do is we add that data to hashes in Redis. And we have an index configured in Redis that's watching for hashes with a certain prefix or keys, in Redis with a certain prefix, and it's indexing all that content in the background. So we add our website data as hashes in index, it gets indexed, and that's indexing. Now let's look at querying. So this is the step I showed you in the demo, right? I want to go and look up, how to connect to Redis with the Python client on the, Redis Cloud documentation. So I start searching for Python. Immediately, the front end starts making search requests to see if it can, get ahead of the game and give me some results that are relevant as soon as possible. So it makes a GET request. That's right over here, this first arrow. We're going to be looking in this direction. So it makes the GET request, and that lands at the search API. The search API does some magic and eventually issues a Redis command, ft.search, against the search index that it's configured to look at. And that does the actual full text search, right, with RediSearch. So RediSearch returns results. The search API packages them up as a JSON response and then sends that to the front end, where the front end does its rendering to give you that beautiful, that beautiful result list. So let's take a quick tour of a couple pieces of the code. I'll show off the site configuration is what we call it. We have a configuration step to point this application at a particular website, because it can actually index any website in theory, and you just sort of configure it and point it there and start it. So look at that. I'll poke around in the index for a couple of seconds just to show you some code there, and then I'll look at the Docker Compose setup for the project, which is a nice way to get an overview of the architecture, I think, when you're looking at any kind of project like this. So let's take a look. Okay, so I'm in my editor here, and I'm in one of the files in this project. It's sitesearch/sites/redislabs.py. This is where I've put all of the site configurations for all the Redis Labs related websites that I've indexed with this thing. So one of them is our documentation site. You can see you sort of just make this variable or this object. It's called site configuration. That's a data class in Python. that takes all these different fields, right? So some of these, you know, are kind of obvious, like the URL. Some of these we pass directly into Scrapey, like I think allowed domains. And then here's where we can configure scoring functions if we want to do some ad hoc scoring adjustments to index time like I talked about. And also we can validate whether we want to actually index something. There's some simple parameters you can give Scrapey, like deny lists, and these will ensure that like when Scrapey's finding things to index, it'll skip certain, you know, things based on a pattern. But also, you know, with the code that we've written, if you want to go deeper and validate, you know, the actual content of a page in case something slips through a deny list, you can do that in these validator functions. And then one more thing we'll talk about is content classes. This is a tuple, like a Python tuple, kind of like a list, where you can give like CSS classes or a CSS ID that says that's the element, the HTML element on the page that this application should look at when it's actually parsing the content for the page out. So why is this important? Well, you know, when you just look at the HTML for a page, there's a bunch of stuff in there, and we really, if we can, we only want to index the part that's relevant. So in a blog, you know, you might have a content or article div where all the actual content for that particular post is at. That's what we want to index. For our documentation site, the class is main content, and that's where the main body of the page shows up. Okay, what else? Let's look at the indexer. This is a bunch of code that handles the transform step. Well, what was it? Well, pretty much all that, all the steps in the indexing section. So the indexer is this class called an indexer, and you know, yada yada. It takes some keys, but you know, we don't have a lot of time, so I encourage you to look at the GitHub repository and check out this code if you're interested. But you can already you can see from this little slice here, right? At some point, we need to take a search document domain object that we've created during parsing and transforming and all that nonsense, and we need to transform it into a dictionary. This is right before we index. We want to pass off a dictionary to the RediSearch Pi client we use to communicate with RediSearch, and that expects a dictionary as input. So we just get a dictionary and send it on in. All right, so let's take a look at one more thing, the Docker Compose file, because like I said, this gives you a nice overview of what we actually deploy when we deploy this app. So we package this app up as multiple Docker images and we deploy them on GCP. So when you're doing local development, you use Docker Compose to orchestrate all those pieces, right? So you, when you're doing local development, you'll have a local Redis, and you'll have a local app server running, and you'll have a worker. The worker is the thing that pulls a job, like an indexing job, that says index this website. And it actually indexes a site configuration, right? Like we were looking at. So that's the thing that's constantly or semi-frequently indexing a website. The scheduler is a process, and all it really does is it just runs and ensures that with a cron-like setup, like I have expressed it as every 60 minutes, I want to run an indexing job. With that kind of setup, it ensures that a job is available, that a job goes into the queue at the right time, basically. It's the library that we use for queuing, which is what the worker and the scheduler are based on, is RQ. So that is a Python queuing library that uses Redis as the backend for jobs. In any event, this is a high-level overview of exactly what we deploy. So this is going to look familiar to you in a minute when I show you the information about deployment. That's my quick dive into the code. Let's switch back to our presentation here. So we looked at site configuration, we looked just a little bit at the indexer code, and we looked at the Docker Compose setup that we have in this project. So here, I wanted to include some information about how we deploy this, because sometimes you don't see this when you hear about an app. Well, how do they deploy this app? Like, how does it even work? So I kind of wanted to give you, this part of the talk, right? So we deploy in multiple regions all over the world. So we deploy on Google Cloud Platform, which I'll refer to as GCP from now on, because Google Cloud Platform, I can't even say it. So for each region, like US West on GCP, we deploy the API, we deploy a scheduler, a worker, and they all go on Compute Engine. And we do that with the feature of Compute Engine that allows you to use a Docker image. So we basically ship a new image, and one of these is instance. Actually, it's all instance groups, right? So that really only matters with the API, because sometimes we want to scale up based on demand. We want to scale up our API servers, and you can do that really easily with instance groups in GCP. Okay, but what about Redis, man? Redis. For the data layer, we deploy via an active geo-replicated cluster on Redis Cloud. So that means we have a local Redis instance in all these different regions. So this is replicated over the entire world. The data is really close to our app servers. It's in the same region, so we have really low latency. And that's super important to burn your fingers off with the speed, which was one of our main goals, right? So bullets are nice. I like bullets. They're easy to type, but sometimes it's good to see a diagram, right? So here's a visual diagram of what I am talking about. So we're looking at one region, right? So all these pieces, we deploy them in each of these regions: US West, US East, Mumbai, Zurich are the regions that we deploy to. So we have a global load balancer. This is really actually, the global load balancer is the only thing that's really not technically per region. It sort of sits at the top and directs API requests to the deployment that's closest to the user, right? So I'm in Portland, Oregon, so I'm going to get the US West deployment here. And when I make a request, it's going to go to a pool of API servers. These are the things that, this is the basically the API image, right? The Docker image that has our API server. And that's using Falcon, this really fast Python web framework that it's like my niche web framework if I want something that's like lightning fast. Falcon. So anyway, that's the search API. They run together like this, like in an instance group like I was talking about. They communicate with Redis Cloud, which is running in the same region via VPC peering. And let's see, what else? I've also added the indexing stuff to this diagram, right? So deployed in this region also is the worker and the scheduler that manage scraping sites and indexing them into Redis. So you can see the worker is the one that does the actual scraping. So there's an arrow where it adds content to Redis. This is the step we talked about where we add hashes to Redis, and then RediSearch indexes them in the background. That's this part. Okay. So let's talk about some benefits of this architecture. It's actually pretty awesome, right? So deploying something across the whole world like this, with some really interesting fault tolerance built into it because of some of these choices is kind of cool. So let's talk about that. So first of all, if the API fails in an entire region, GCP's load balancer will redirect traffic to another region. It's a global load balancer. So if US West goes down, I'm going to get the US East application server. It's not going to burn my fingers off to the bone, but maybe it'll just scorch me a little. It'll still be kind of fast. That's pretty awesome. But here's something else that's really interesting, right? And this is the hard engineering stuff, right? So indexing, when we actually index websites, that actually happens in all regions that we deploy to, because as I said, we deploy the indexer in every region. So what that means though is that normally if that's called a multi-master setup, right? Or active. That means that all those regions are writing data. So normally that might be a problem if you want them all to share data and sort of replicate the same data. But this uses Redis Cloud's active deployment, and with CRDTs, we can resolve those conflicts, right? So all the indexers can be indexing content, and CRDTs will make sure that Redis is able to coordinate synchronizing that state. So it's pretty cool. What does that actually mean? Okay. Engineering wise, that's interesting. CRDTs are cool. But what that actually means for our application is that the indexer process and the scheduler could go down in all but one of these regions. So like you could have just one indexer standing in Mumbai, and because, you know, or even just two, right? Because, because we have this setup, these indexers going down is not going to take down the indexing step. So we're even more fault tolerant. Anyway, very cool stuff. What else? This is a sort of standard thing when you split up the deployment like this. We have multiple instance groups, which means we can scale our workers independently of our API servers, but also we can scale Redis. We can scale in Redis Cloud to the moon. All right, so that was what I wanted to show you. I wanted to talk about why we built this thing, what it was we built, demo it, kind of talk a little bit about behind the scenes. This code that I showed off is all open source. This is a production application that runs our documentation website search, and you can also use this code. It's not a library, it's actually just a straight up open source Python application. So you can see exactly the code that we use to run this thing. You can get it on GitHub. And I've also open sourced the front end for this, which is might be a little harder to use. I'm not much of a front end developer, but you can find the code here. It's based off an open source autocomplete widget. Component is what we're supposed to say in 2021 about JavaScript component stuff. Okay, so anyway, check those slides out. Check these slides out and look at the links here. You can find a lot of links on this page, more resources. Some of the other links I wanted to talk about are Redis University. I work on Redis University stuff. Those are courses that you can take to learn about Redis. We also have a Discord server. It's public, so sure, it would be great if you clicked on this link. That'll work for you. But if you don't click on the link, if you can't get the slides, you can just search for it in Discord. It's a public server. What else? Okay, and there's also a blog post on our blog about how I built this thing, how we built this thing, the first version. The first version was like, how fast can I actually do this? So, it was a simpler version. So check that out because that's interesting too, right? From a different perspective. Anyway, thanks for coming to this talk. Connect with me if you're interested to learn about Redis. I'm at andrewbrookins.com or abrookins on Twitter. And yeah, I appreciate your time.